Hello. Ay, hello. Good.
Action!
Where's my pen? Ay, hello.
Action!
Ay, take one. Ay, hello, good day, good afternoon.
Action!
Take two. Ay, hello, good day, everyone. Good afternoon, good evening, good morning. And it's been a while since my last upload. Ay, again. Ay. Hello, good day everyone, and good morning, good evening, and it's been a while since my last upload. Okay, I have been very sick. I have been coughing real hard, coughing, sneezing, and everything because it's basically winter now here in my place. Okay, and I've been feeling the flu. Okay, now but right now we're good. We're back, and today we're gonna be doing more examples, and we have a lot of examples here. A mystery sender, wink wink. No, I don't know who it is, but someone sent me their activity or their quiz, and they're asking if we can solve it. Now take note, or do note that we're solving this after they have checked their activity. So we're not we're trying to help them understand, but it's not some kind of leakage, it's not some kind of answer to an assignment that they should learn for themselves. Okay, anyways, let's get started. Hi, let's get started. Hi, so first, let's read the situation first. Okay, determine whether the following differential equation is separable equations, separable variables, equations of homogeneous equations, exact equations, linear equations. The first four type. After finding the type equation, solve for the general solution, determine the degree of homogeneity if it is a homogeneous equation, and test for exactness if it's an exact equation. You must. Okay. Let's start with number one. Okay, let's start with number one. Let's go direct to the point. So take note, if we have if this take too much time, we may resort to cutting the video into parts. Okay, we may resort to cutting the video into parts. So feel free to cut the video or check out the other videos, or feel free to skip some of the videos if you already know the answer to this specific differential equation. Okay, so first off, we have a differential equation. Let's write that up first. Okay, so I'm gonna write them. So my writing is still disgusting. Writing is bad. Okay, but just make sure that your x and y are basically not the same. This is your y, and this is your x. Okay, sometimes some x are like this. That's not an x, that's a y. No, sometimes someone's y is like this. Okay, it looks like an x, but it's a y. So make sure that your handwriting is not confusing to yourself or to your instructor. Okay, so take note, or I'm just noticing that there's a lot of x and y here, second degree. Or let's just test for homogeneity. Okay, let y equals lambda y, let x is equal to lambda x. Okay, lambda y, 2 lambda squared x squared minus lambda x lambda y plus lambda squared minus lambda squared x squared 2 lambda x minus lambda y dy. Okay, take note that we have lambda cube. If we take out the lambda from all of the variables, we're gonna have a lambda cube. Okay, where's the y outside? Okay, y, 2x squared minus xy plus y squared dx, oh, we forgot the dx, minus the lambda is already been taken out, x squared, 2x minus y dy, okay, is equal to 0. Okay, therefore we can say this is homogeneous of lambda or degree 3. Okay, that's how you test for homogeneity. You basically substitute your variable with lambda, your y with lambda y, x with lambda x, and you separate it like a coefficient, right? So this becomes lambda squared, lambda squared times lambda is lambda cube. And every term will have a lambda cube if that's homogeneous. But if, well, let's check. This is lambda squared, this is lambda squared, this is lambda squared multiplied to lambda 1, that's become lambda cube, right? This is lambda 1, this is lambda 1 multiplied to lambda squared, that will become lambda cube. Okay? Okay, so that's how you test for homogeneity. Just a reminder for the, just for the reminder for homogeneous equation. Okay, now to solve. Okay, to solve, let's just substitute, or I'm gonna write the equation again. Wink, wink. I say I write, but I'm just gonna copy it from the above because we're using paint. Okay. Now, we substitute y is equal to vx and dy is equal to vdx plus x dv. That's how we solve for homogeneous equation. Right? So, vx 2v squared x squared minus vx. Okay. I got confused. We substitute y. Okay. So always double check what you are substituting. Substitute. Okay. Okay. I'm still sick, everyone. I'm still coughing. So if I'm mispronouncing other words, I'm sorry. Okay. Alright, so we only substituted y with vx, right? Okay, it doesn't matter if you're slow or not, but if you do it once, if you only write it once, or if you only do your equation once correctly, you're gonna be faster than everyone else, or you're gonna solve your equation faster than doing it fast twice wrong, right? Then multiply it. Also, I'm gonna write it a little, smaller. V x cubed 2, right? Dx minus v squared x cubed dx plus v cubed x cubed dx minus 2x cubed v dx. Alright, I'm gonna multiply dx first, right? Plus v x cubed dx. Okay, take note, all dx have x cubed. Okay, all the dx have x cubed. See, x cubed, x cubed, x cubed, x cubed, x cubed. Okay, there seems to be a pattern in homogeneous equations, right? Plus, let's do the x dv. Let's do the x dv. Negative 2x to the 4th dv plus v x to the 4th dv, okay, is equal to 0. Okay, I'm gonna double check. Let's solve. 2vx cubed, vx cubed. So let's cancel that. V cubed, v square x cubed. There's nothing v square x cubed. Wait, chutomate. This should be v square x cube, right? Because this is v, this is v, right? That should be vx squared x cube, right? V squared x cube. Alright, for the first, I think this should be, okay, so v squared x cube, this will get cancelled, alright? Then 2x cube v, 2x cube v, positive and negative, this will be cancelled. Okay, let's simplify. V cube x cube dx minus 2x to the fourth dv plus v x to the fourth dv is equals 0. Applying some algebra, okay, common multiple, v cube x cube dx, because these have x to the fourth, right? X to the fourth positive, v minus 2 dv, right, is equal to 0. Divide both sides by x to the fourth and v cube x cube dx over x to the fourth. Basically, they are separable now. V minus 2 over v cube dv. Okay? They are now separable. Okay? We separate the v and the x to their respective variable, to which x to the fourth dv, x to the fourth should be switched to the left side, and v cube dx, v cube should be switched to the right side, right? Okay, so this will become dx, cancel, over x plus v over v cube minus 2 over v cube. Okay, property of fraction. Okay, so the numerator can be separated into two fractions with the same denominator. That's a property of fraction. Okay, and if we integrate them, let's just integrate. This will become ln x. Now we're gonna cancel the v, right? That will become squared. Okay. Plus, okay, 1 over v negative, that's gonna be v squared, that will become v, right? Negative. Then minus 2 over v squared negative 2 plus is equal to c. Is equal to c. Okay, so we're gonna cancel negative 2. That's gonna become positive. We're gonna multiply both sides to b squared. Multiply both sides to b squared. So this will become v squared ln x minus v plus 1 is equal to c v squared. Don't forget the c, because most of the ones, or sometimes when I do it, I forget the c. So don't forget the c. You know, he has a heart too. You know, he has feelings. If you forget the c, he will be. That doesn't look like a sad face. He will be sad. Anyways, just kidding. Okay, now that's not the final answer, because the final answer needs to be the same variable as the given. And we substituted the given with y equals vx, right? So we just have to replace the value. V is equal to y over x, y is equal to vx, right? So v is equal to y over x, y squared over x squared ln x minus y over x plus 1 is equal to cy squared over x squared. Let's take up the fraction by multiplying x squared to both sides. So y squared ln x minus yx plus x squared is equal to cy squared. And this is now your general solution. Okay, I hope you guys uh well, if I'm talking too fast, I hope you guys learned something. But if I'm talking too fast, yeah, I hope you understand. But if I'm talking too fast, you guys could slow down the video, okay? Or print screen, or basically I'm just gonna like zoom out. And this is the solution for our number one. I wonder how many minutes. Let's check the video. I think that's 14 minutes. I think we took 14 minutes for one problem. Okay, let's kick it up a notch. Let's solve another one. Oh, wrong one. Okay, let's solve another one. Okay. So this one is a homogeneous equation. Let's see if the next equation is also homogeneous. Okay, so this one is trigonometric. Okay, this one is trigonometric. Okay, so first, I want to write this down. 3 cosine y dx. There's a parenthesis here, so that's like 12 sine y dy. Okay. Okay. I'm what do you call that? I don't want any dx or any variable at the opposite side. No. I'm always more comfortable in having them at the same side. So I'm gonna move the other one first. Because if it's not on the same side, you have to be on the same side. Friends would need to be in the same side. DX. I don't know why I'm calling them friends, but they're both DX. Oh, I don't change the variable though. Okay, there we go. I simply move the dx to the opposite side. Then take out the dx, so that's 3 cosine y minus 1 dx plus 12 sine y dy. Okay, at first this looks like a linear equation, but it seems to be a separable equation. Let's do a separable process. Simply separate. Divide by the change. Okay, so this will become dx 0 is equal to dx plus 12 sine y dy over 3 cosine y minus 1. Okay, separable equation. Okay. And if we let u is equal to 3 cosine y minus 1, du is gonna be negative 3 sine y. Alright, dy. I hope you still remember the formulas for integral equation, because if you don't remember the differential of cosine y to sine dy, that's an integral or differential topic. Okay? Please remember the formula. Or basically, you just have learned it. Right? Cosine y, the differential of cosine y is negative sine y. You have learned it from me. No. Say thank you by subscribing. Just kidding. Just kidding. If you guys have learned, and I'm happy. Okay. But it will certainly help if you subscribe. Anyways, let's continue. Shut up now. Okay. Alright. What to do? Oh yeah, we substitute. Dx plus negative 3 sine y. So I'm gonna take out the 4. Negative positive 3 sine y dy, right? Over 3 cosine y minus 1, right? Is equal to 0. So we substitute the du. So this will become negative 4 du over u is equal to 0. We integrate now. Integrate x minus 4 ln u is equal to c. x minus ln u. We can, we're simply just simplifying now. So I'm just gonna put it at the opposite side. Is equal to c plus 4 ln u. Or we, okay, how about let's do this. I'm gonna put c, or I'm gonna make c ln. Okay, ln c. X is equal to ln c plus 4 ln u is equal to ln c plus ln u to the fourth is equal to ln cu to the fourth. Yeah. See you when I see you. When I see you. Alright, anyways. X is equal to ln cu to the fourth. Raise both sides to e. This will become e to the x is equal to cu to the fourth. Okay? Now, that's not the final answer, because remember, the final answer needs to be the same variable as the given. We let u is equal to 3 cosine y minus 1. That's not cosine y, that's coy. What's coy? Cosine y minus 1. So the final answer will be ex is equal to c 3 cosine y minus 1 to the 4. Alright, this is now your final answer. Okay. If you guys didn't use ln c, that's okay too. If you guys didn't use ln c, just put c. This is okay too. Just substitute u. But for simplification purposes, I think this is more compact, you know. This is okay too. If you guys didn't use lnc, just use c. Then simply substitute u with the 3 cosine y minus 1, and that's the final answer. Okay. Okay. So we seems to be doing good. Okay. That's how many minutes for that? 7 minutes. Nice. Okay, we're speeding up. Okay. Next. Number 3. Okay, it is important that we know the type. Okay, the key ingredient, or always the key factor, is we know the type of equation. Okay. So in this type, okay, here's the thing. Okay, one clue. If there's a trigonometric function, or there's a different identity in the equation, it's not homogeneous. Homogeneous tends to be like the same variable, or just x and y. Or if there's a trigonometric function, it's 0, or the sum total is 0 degree. So this one, 2x plus y cosine xy dx plus x cosine xy dy is equal to 0. This one is bracket. Okay. So we have separable, we have homogeneous. So I'm guessing this will be exact or linear. I'm leaning towards exact. Okay, let's try exact. Okay, this cannot be homogeneous. For example, okay, this is not the same degree as this one. Right? There's 3 variables here. There's 1 variable there. That cannot be homogeneous. And it could be separable, but I cannot separate x and y inside the trigonometric function without using identities. I bet we can. Probably we can use identities, but I'm not towards pain. And I don't like pain. I don't like hard problems. Okay, so I'm gonna go exact first before we go separable. If we can solve it by exact, we might use identities, but I don't want hard problems. Okay, let's make it easy for us. Okay, so m with respect to y, right? So we're just gonna look at y. This one will become 0. Then because there's 2y here, okay, let's do the first y first. The differential of y will become cosine xy, just 1. Okay. Next is the differential of the y in the cosine. It will become yx negative sine xy. Okay. Then for the n with respect to x, differential of x will be cosine xy. It seems to be exact. And the differential of cosine x is negative yx sine xy. Okay. Therefore, they are exact. Okay. Cool. They are exact. Alright, so let's solve for exact. Simply integrate both sides. Okay, the integral of 2x. The integral of 2x is x squared. Okay, the integral of y cosine xy, we're only looking at the x now. Because this is mdx. So we're only looking at the x. Okay, is y sine xy divided by y plus f of y. At the opposite side, the integral of n dy, which is x cosine xy, it will become sine xy, right? X sine xy over x plus g of x. So g of x is x squared because this is the only x term at the opposite side, and f of y is 0 because there's no y term on the opposite side. We could cancel this, and this is the similar term, the sine xy. Okay, I hope you guys are hearing my dad singing, you know, the old songs. Anyways, this is the general solution. Is equal to C. Okay, this is now our general solution. Okay, I haven't taught inspection yet, right? So I haven't taught inspection yet. Maybe when we have our inspection topic, we could solve this. Because apparently we could solve, just looking at it, we could solve it via inspection. Okay? We can solve it. Why the heck? Why the heck? We have time. How many minutes have we're doing this? 30 minutes. 30 minutes, we have solved already almost half. Or going half. So let's solve this via inspection. Why the heck? Why not? Let's hope that the other problem is not hard. Okay? Or not long. Okay? So, writing this down, what is inspection? Basically, inspection is the fifth type of differential equation. After this 4, we have the fifth type. Okay? Solving equation via inspection. Inspection is basically brute forcing your equation. Okay? Brute forcing your equation into a much simpler equation, or integrating your equation manually. Okay? How do you do that? You can only do that to simple differential equation. Okay? Simple differential equation. In order to know that a differential equation is simple, you need to have a lot of experience. Okay? A lot of experience, and solving a lot of differential equation will make, basically, if you solve, it will make you a veteran, and it will make others differential equation like common to you. Okay? So for example, one of the most common thing to look out for inspection is the differential of xy. Basically, that's the product rule. If you differentiate that, that's the x dy plus y dx. Okay? So I'm gonna distribute the equation first. So this becomes 2x dx plus y cosine xy dx plus x cosine xy dy. You guys see it? Okay. I'm gonna take out cosine xy at these two terms. So plus cosine xy. This will become y dx plus x dy. Okay. Meaning, this two term is a product rule. 2x dx plus cosine xy differential of xy is equal to 0, meaning this is a product rule, and we can simply let u is equal to xy, meaning this is cosine u du is equal to 0, right? 2x dx. And we can integrate that very easily without doing our inspection and stuff. You know, it's a lot more simpler, it's a lot more easier, but only to this problem, because we're just lucky that we have this equation. Okay, sine u is xy, so this is equal to x squared plus sine xy is equal to c. This is now our general solution. Okay, and it takes a lot of experience to notice or to find y dx and x dy. Okay, it takes a lot of experience. Okay, so if you guys want to brute force any equation, you can do that. Okay, probably, can you brute force this? I don't have the mind for it. I don't want to think about it. I don't have the mind for brute forcing any equation. No, no. No, not now. Okay. Alright. Anyways, let's solve for number 4. Okay, we're in a row. Okay, let's solve for number 4. Last for our part 2, right? Last problem for our part 2. So it seems that our part 2 is IVP, or initial value problem. Let's not forget a equals 0 and k equals 2. Okay, so let's write out 2a cubed minus 2ka dA is equal to dk. Okay. How do I say this? They're not separable. It's not homogeneous. And if we test for exact, 0 minus 2a zero. So it's not exact, right? So let's test for, it's not homogeneous because this is a cubed and this is squared and this is basically 0 variable. So it's not homogeneous. It's not separable because they're both polynomial. So what's left is linear. Okay, because a is a cube, and when you say linear, it needs to be first degree. I'm leaning towards k as the dependent variable. So let's divide both sides. I'm gonna delete this. Because it's not exact, so it's not part of the equation. Okay, in solving that. So let's do linear with k. Let's divide both sides by dA. Divide both sides by dA. So this will become 2a cubed minus 2ka is equal to dk over dA. Okay, so we have our dependent variable now for our linear equation. Remember, dependent variable plus whatever your dependent variable is, your first degree dependent variable, then your whatever your variable is. Okay, go. So we look at our first degree, we put it at the opposite side, so we become 2a k is equal to 2a cubed. Okay, then we use our Yapex depex. Alright, Yapex. No, wrong one. Yapex dix dix. Okay, this one. Okay, we use our all powerful formula. Yapex dex kedex pedex dex. Okay, or simply find your integrating factor. Your integrating factor will become PA, right? Or in this case, this will become KE to the PADA is equal to QA e to the integral of PADA, right? Your PA is 2A and your QA is 2AQ. Are you A-okay? Yay! I'm sorry. Sorry for the dad jokes. Okay, anyways, KE. Now our PA is 2A, so integral of 2A dA is equal to Q A e to the integral of P or 2A. Now let's just substitute it, right? 2A cubed E integral of 2A dA. So this will become KE A squared is equal to integral of 2A cubed E A squared dA. Well, we could offer up. Let's get more space, right? Let's get more space. We can get solve this. Let's solve this, right? Alright. So, how do we integrate this? Alright, we can integrate this. Let A squared is equal to U. Du is equal to 2A dA. Okay, we separate A cubed into 2A squared A squared dA. So the 2A dA is du and A squared is U. So this become U squared, this one, EU squared. Oh wait, it's not U squared, it's U, only U. Okay. Then the 2A dA is du. Okay. Oh, this is only U2. Okay, there we go. And this will become, this is basically what I call this is the mascot of integration by parts. Okay, UB dBU, right? So this will become U e to the U minus integral of e to the U du. Okay, and the integral of e to the U du is negative e to the U du. This is equal to KE A squared. Okay, plus C. Okay, so let's take out the du. Because the integral of, when we integrate, we already take out the differential. Okay, the substitute U, KE A squared is equal to A squared E A squared minus E A squared plus C. Okay, simplify it further. Let's divide it by E A squared. Divide, right? So this from K is equal to A squared minus 1 plus C E A squared negative. And this is an IBP. Don't forget. Okay? Sometimes people forget, oh, I have the general equation to solve. Okay, this is a IBP, so we substitute. K is 2. A is 0, no? So 2 is equal to 0 squared minus 1 plus C e raised to negative 0 squared. Anything raised to 0 is 1. So this will become 2 is equal to negative 1 plus C. C is equal to 3. And our particular solution now is plus 3e negative a squared. This is now our particular solution and the answer to number 4. Alright. Happy with that. I hope you guys learned something. This will be our part 1 of our problem solving. Someone asked me before if he or she can get the pink or the, what you call that, this file. You know, you guys could comment your email and I could send it to you guys if you want to get the file of this paint, this file, and I could send it to you guys for the solution. Okay, but it will be much better if you guys like watch the video, try to learn it, and do it yourself, right? Not just like take the picture, take the file, and study about it, right? It's much better if you guys solve for it. You do it. Well, if it's a written exam, you do it hands on. Okay, so for me, differential equation is more of a skill. It's not something you study, but it's something you sharpen. Okay, it's something you sharpen, you do every day. Okay, so this is part 2. Well, technically part 2. This first part 1, because this is the first thing we do. So we're gonna continue to the second part where what's this? Seems to be we're gonna be solving inspection by other methods, non-exact made excels, and by other methods. Okay, we'll be solving the latter type. I hope you guys have learned. Okay, I will make another video, and thank you so much for watching. And yeah, let's continue to part 2.